Hello students, and welcome to the last video of this lesson. In this video, we're going to be actually taking what we've known about derivatives and the context of those situations and how we can use derivatives to solve real life scenarios, and we're going to apply antiderivatives and integrals to those. So let's get started. So here we're looking at a shrub, and we're given some information here about the derivative. So the rate at which that height is changing in terms of t, which is measured in years. So in this first part, we want to find, okay, what is the value of this differential equation when t equals 3? So let's evaluate it here. So dh dt equals 1.5 times 3 plus 5. And so 1.5 times 3 is going to get me 4.5 plus 5, that's going to be 9.5. And let me think about the units of measure. That's going to be centimeters per year, so that's going to be centimeters per year. So what does this mean in terms of the context of the problem? So t is going to be 3 years. So after 3 years, we know that our shrub is growing at a rate of 9.5 centimeters per year, which doesn't seem like that much. It's a pretty slow growing shrub. All right, so now let's look at our second problem. And it says, we want to find an equation for h of t. Well, we're not given any information about h of t, but we do know the derivative. And so since I want to go from the derivative up to the original function, I need the antiderivative. So we're going to find the antiderivative of dh dt with respect to dt, with respect to time. So that's what's going to get me the height of the shrub plus some constant, because the shrub has an initial amount, an initial value, and we're going to need to add in that constant. Where did it start with? All right, so let's find this antiderivative first. So we're going to go here. This is going to be 1.5 t plus 5 dt, and that is going to get me, add 1 to the exponent, so 1.5 t squared over 2 plus 5t over 1 plus my constant. So the height, h of t, with the constant value is going to be 1.5 divided by 2, that's 0.75. So 0.75 t squared plus 5t plus c. Now there is some information in the problem that is going to help us out, and that we know that the seedlings are 12 centimeters tall when planted at t equals 0. So we know that h of 0 is going to be 12. So we need to keep that into account. So if I do find this, if I find h of 0, that's going to be 0.750 squared plus 5 times 0 plus c, we know that that is going to be equal to 12. And so since everything gets multiplied by 0, we know that c equals 12. So what I know is that h of t, my true function for h of t without the constant, or the constant value that we do know, is going to be 0.75 t squared plus 5t plus 12. So now we want to determine how tall the shrubs are when they're sold. And remember, in the problem, it says that we sell those shrubs at 6 years. So we want to find what is the height of the shrub at 6 years. So h of 6. So let's figure this out. 0.75, 6 squared plus 5 times 6 plus 12. We evaluate all of that and we get 69 centimeters. Again, keeping in account the units of measure that we have. So we really have to hold on to these shrubs for a really long time in order to sell them at a height that's going to be desirable to those customers. So based off of what you've learned here, knowing that you can now go not just down in your functions to find derivatives, but taking that derivative and going up to those initial values and being able to find more information about height, speed, things like that. I want you guys to take this here. Keep in mind that velocity is really just the derivative of the position function. And I want you guys to attempt our second problem. Okay, and that is going to conclude our final problem here in this lesson. You do have the homework coming up so that you can practice even more. But remember what I said all the way back of learning derivatives. If you don't have derivatives down, then these problems are going to feel impossible. because now you're flipping your mind and you're trying to go in that opposite direction. If you didn't get this answer, or if you're struggling with any of the problems in any of these lessons, please reach out to me so that I can help. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.